Hey, you guys. Sorry I'm not here, but I wanted to let you have a little bit of information about this section and just try your best on the homework problems. But this PowerPoint is the PowerPoint on section 7.1, and it refers to or it uses a lot of identities. So you're going to have to use these identities in this first section to do basic algebra um, techniques. So let me show you what those identities are, and you should uh, make sure you copy these down, and I'll just, you can access this on Moodle, and so I'll just run through some examples with you using these identities. Um, Let me see if I can get to them. Okay, the first set of identities, these are called the reciprocal identities, and you're probably familiar with these. These are, the cosecant is 1 divided by the sine, and the secant is 1 divided by the cosine. So these should be familiar to you. So these are the reciprocal identities. The next set are the odd even identities. And these are the ones we talked to you about with the graphing and the negative signs. The first four, the negative signs come out. These are called the odd ones. Um, the next set are called the even ones. Those are the ones where the negative sign basically disappears. So those are cosine and secant. So if you got a negative x here, you may want to look at these in particular, and what you need to do is just take those negatives off if it's the cosine or the sine. Okay, so those are the odd even identities. Um, okay, the next set of identities are called the ratio identities. Tan is sine divided by cosine, and that's because sine and cosine are, tan is y divided by x. So y is sine and x is cosine, and cotan is the reciprocal. Cotan is x divided by y, so you're seeing that y, the cotan is cosine divided by sine. Um, okay, so let's see. So those are the ratio identities. Then we have the Pythagorean identities. And if you look up here at the top, this is the main one. Um, and that comes from the fact that when you're on the unit circle, y squared plus x squared equal 1 squared from the Pythagorean theorem. And again, remember, y is your sine and x is your cosine, so that's why that one's true. If you take one, like for this one, you're moving the sine squared over to the right side, so it becomes 1 minus sine squared equal cosine squared. For the second identity, you're basically moving the cosine squared over to the right side. So there are variations on that main formula that you could use. You see these two a lot, so you want to replace 1 minus sine squared with cosine squared and so forth. Okay, so let me show you a few more variations of that one. The other Pythagorean identities that come from the main one are 1 plus cotan squared equal cosecant squared and 1 plus tan squared equals secant squared. Okay, so we're going to use all these identities. I'm going to switch now to some examples, and so I want to get to those. So let me get to my blank things. Okay, so we're basically using some algebra to simplify these things. So the first example is this one. The instructions are for me to just simplify this, and that's a bit of a vague term that you'll have to come to grips with. What does simplify mean? And I'm going to try to do some examples to show you what simplify means. But this first example, the directions tell you to multiply and simplify. So this is let me write it down. So 1 plus tan x squared. Okay. And what you want to do here is just to write it down twice. I'm trying to use a pen and it's not showing up too well, so that's what square means. We have to write it down twice. So that's what I'm trying to show you there. It looks kind of bad. But we're going to FOIL that out. So you remember how you do that? You multiply the first terms together. So 1 times 1 is 1. And then the outer terms, 1 times the tan x is tan x. The inner terms give you the same thing this time because we are squaring it. So the inner terms also give me tan x. And then the last term, see how you've got tan times tan? So we write that as tan squared x. And see where I'm putting the power? That's what tan squared means. That means the same thing as tan times tan. So if you collect your similar terms here, that gives you 1 plus 2 tan x plus tan squared x. Okay, now, so you've done everything you can in terms of multiplying, but what you want to look at here is your is whether or not you can see an identity. And this is an identity. So let me show you the identity here that I'm seeing. This and this. And I don't know if you remember or not, but if you go find it back on Pythagorean identities, you see that 1 plus tan squared is secant squared. So so that should be secant squared x. So let me move to my next blank shot. So I had 1 plus 2 tan x plus tan squared. And that I want to replace with secant squared x. And then I still have my 2 tan x. So that's what they wanted you to do there, is just to multiply stuff out and then see if you can come up with an identity. Okay, let me move to another question. So okay, so another question. Let's see. So if I've got this one, this is also so now we're told to factor and simplify. Okay, so this problem that I'm looking at is, this is number 2. So this is 2 cosine squared x plus cosine x minus 3. Okay, so you want to think about the cosine x as being like x. So you really have a quadratic equation. And so we can factor quadratics and by trying to get that first term. So we try to get 2 cosine squared x, and we can do that by writing 2 cosine x. I'm not going to have enough room, so let me fix that. So I can write that as 2 cosine x, and this would need to be cosine x, because that would give you the 2 cosine x squared. Now, remember you have the minus 3, so if I'm trying to get my 3, I need to put my 3 and my 1 in a certain place to factor correctly. So if I put my plus 3 here and a minus 1 there, that's going to give me a negative 3. and that will full out correctly to give me that equation. So you're just factoring with cosine like you do with x, and that's how you factor. This just has to FOIL out to give you that problem up there, just like in algebra. Okay, let me try one more. So this problem is 3 cotan squared beta plus 6 cotan beta plus 3. Okay. Now the thing about this one is this one has a greatest common factor. If you look at the numbers in front of each term, you can factor out a 3. So that's the first step in factoring always. So I can factor out that common factor, and that leaves me with cotan squared beta plus 2 cotan beta plus 1. And then I can further factor the square problem like I did earlier. So remember, we're trying to get cotan squared, so I can get cotan. I can get that by doing cotan beta here and here. That gives me cotan squared. And then I'm trying to get the 1. So to get the 1, I can just put a plus 1 in both slots. And if you full that out, that does give you the quadratic equation up above there. So that's how you factor. Okay. I think that I will do a separate video on some more examples later.